Hello everyone, my name is Professor Songju Lee at the School of Electrical Engineering at KAIST, and I lead the Networking and Mobile Systems Lab. So just a little bit about myself. So I received my PhD in computer science in 2000 at UCLA, which is the birthplace of the internet. So what is a little bit unique about myself compared to other KAIST professors is that I actually had 15 years of industry experience in the Silicon Valley before coming to KAIST in 2015. So I had many different experiences in the Valley, working in large companies such as Hewlett-Packard, playing a role of distinguished mobility architect, but also worked in a startup called Narus, which is now part of Symantec. And as I mentioned, in 2015, I joined KAIST. So a little bit about my accomplishments. I have high citation counts in H-index. Since I work in the industry, I value very practical research. So I have had some technical transfers, as well as 51 granted US patents. I have chaired in the capacity of general chair and technical program co-chair of the most important conferences in my area. And I have also won numerous awards, including HP CEO Innovation Award, which is awarded to the people who impacted the company with technical innovation, and also Best Paper Awards from different top conferences, as well as the Test of Time Paper Award at an ACM conference. I am an IEEE Fellow, a STEM Distinguished Scientist, and also a KAIST Endowed Chair Professor. So about the lab. So my background before coming to KAIST was mostly in networks and wireless networking, working on various aspects of protocols such as Wi-Fi that we all use every day. Since joining KAIST, I have worked on those areas, as well as some new areas that are more close to the human side of computing. So in one sentence, I would describe my lab as an MSL that utilizes expertise in mobile computing, machine learning, human-computer interactions, and network systems to build innovative services and applications. So our research philosophy is that we're grounded on fundamental novelty, but we also want to make practical impact. So we want to have the balance of both. So our research lab has diverse research topics, but we can categorize largely into 4 areas, which I will delve into deeply. But first is ubiquitous sensing. The second would be machine learning and artificial intelligence for mobile computing. Third is human-computer interactions for mobility, and also mobile computing and networking. So let's first look into ubiquitous sensing. So one of the research philosophy that I mentioned is practical impact. Now, you could make new hardware or software and so forth, but it's very difficult to be deployed when not everybody has it. So one of the key things that we want to tackle was that let's utilize something that people already have, which is a smartphone. Now, smartphone has a lot of sensors built in, so we can utilize those. And if we combine them with the machine learning, we can actually provide innovative services. So the first example of that is called Knocker, where if you knock an object with only your smartphone, we can actually identify what that object is. And on plus of that, we can tell what kind of interactions that you do with certain objects. So we can automatically launch those applications as soon as you knock with your phone, and then you have the service that you desire. So the sensors that we use here is sound, but also motion sensors. So this is an example of multimodal artificial intelligence, and combine that with the hardware that you already carry every day, and the interaction aspect where let's say if you touch the water bottle, it would automatically go to your favorite online store to order the water that you drink. The other part is that we actually built a hardware as well, a wearable. So food journaling is actually a very important aspect of health, and your doctor also recommend that you do it. but a lot of times we forget. So there have been a lot of wearable devices that has been proposed, but some of the limitation was their form factor was too large, and also some of them were socially not acceptable for you to wear every day. So we are motivated to build something where we can just put it in your own wearable, which could be eyeglasses. So even in eyeglasses, people have different styles, so they want to have different frames. So we built a very small device where you can just attach it or clip it into your frame, and then you can actually detect the movement of your jaws, and then we can detect that you're eating. So here we also use multimodal AI, where we use the motion sensor like the accelerometer and also piezo sensor to complement each other. So this is called MyDJ. Now going into the second area, which is machine learning and artificial intelligence. So this was actually motivated by some of our work from the ubiquitous sensing. As we develop a machine learning model and train, we used a same smartphone and with some users. But we found out that different devices actually have different types of sensors. The quality of sensors are different, and even the location within the phone of those sensors were different. With those differences, the model that we trained for machine learning weren't performing as well when deployed to these untrained conditions. So motivated from this fact, we started looking to how we can overcome this problem. Because if you think about all the different smartphones, and different people also behave very differently with the phones, even with a simple motion. So there are countless conditions that's just impossible to train. So what we did was utilize something called meta learning, which is learning how to learn. So we took meta learning, and we had to actually make it work in our mobile sensing scenario. So we created some task generation techniques that is unique for our domain. So we were the first to actually use meta learning, and we actually showed very good performance. Now, along the same lines, test time adaptation has been very popular. So previously, we had something called domain adaptation, where you adapt to conditions that weren't trained. But this was, the adaptation was done before deployment, but also required a lot of data. However, test time adaptation is different from that. The key advantage here is that we don't really have to collect data after deployment, and also the adaptation is done after deployment. However, most existing work had an assumption that data were identically and independent and identical distributed, which isn't quite true in mobile computing scenarios. So if you think about, let's say, for activity recognition, if you're walking, the way you walk is actually temporally correlated, right? It's not completely independent. So we had to come up with some new innovative mechanism for test time adaptation to work in these scenarios. So we came up with two main components, which is instant aware batch normalization and also prediction balanced reservoir sampling. So in combination, it made test time adaptation perform much better when the data has temporal correlation. Our follow-on work on this was to actually handle noisy samples, because when you're actually trying to do adaptation, not all data are actually benign. So again, we had to devise two different components. One is to input-wise robustness. So this is basically a mechanism that avoids selecting noisy samples during the model updates, but also parameter-wise robustness. Basically, this is an entropy sharpness minimization that makes the parameter resilience to weight perturbation based on noisy samples. And another line of research on machine learning is federated learning, which has been gaining huge momentum both in academia and industry, because it allows on-device learning, and which is very important when privacy is utmost importance for instance, healthcare data. So in the federated learning cases, existing works actually treated all clients equally, which is again not true in most scenarios because all different devices would have different hardware capability, but also data as well. Not all data come at the same time, at the same speed. So there are a lot of imbalance happening in federated learning. So we proposed a way to handle this heterogeneity by actually not treating each data samples equally, but we came up with an innovative way to actually decide the importance of each data, and based on that, we give different weights. And also, when we're training, we also provided some kind of a deadline that's actually adaptive based on the status of all the clients. And with that adaptive deadline, in addition to the sample selection, we were able to achieve very high speed up as well as achieving higher accuracy. So by utilizing federated learning, we actually built a pretty cool service. So mental issues or mental health monitoring obviously is very important for many people. And those who actually get diagnosed for depression, for instance, the early detection is very important, but a lot of people actually don't even realize they have it. So there have been many smartphone-based services to detect mood and depression, and they typically use the smartphone usage patterns and so forth. However, if you actually talk to medical experts, the way they diagnose people's depression is based on their linguistic usage. Now, since we use smartphone every day, whether it's an audio input, but also keyboard input, we actually use linguistics quite a bit. However, previous work were not able to utilize this because of the privacy issues, but now with federated learning, this is actually possible. So we had built something called Fed Therapist that selectively utilize your audio input and keyboard input without violating any privacy issues, and combine that with the context that you're in, time of day, who you're with. We were actually able to detect whether this person is mentally healthy or whether they need to go see a real therapist to see if they're okay. So this is one of the applications that we built on top of federated learning. One last thing on the mobile AI space, the chat is still one of the popular apps that we use on our smartphones, but a picture says 1,000 words. For instance, this was motivated by one of the exchange students that was in my class. He wanted to explain one of the food cuisine that he was from, so he wanted to eat that, but he couldn't quite explain that to his friends in Korea. So he wanted to build a tool where when he types on a chat, we can actually suggest images. So this is almost like a Google autofill, but only with images. Now this is very cool, but also very hard because this has to be done in real time and it has to be done on device. So we utilize some of the NLP tools for on-device AI to actually provide this service. So next one is mobile human-computer interaction. So as we use smartphones every day, we actually get quite a bit of notifications. And sometimes this gets in the way of the real social networking that I do and also doing the work. Because it just comes up like almost every minute. Now, so first we want to focus on actual social setting. If you're with somebody socializing, these notifications interfere. So what we did was detect the context you're in. For instance, if there's silence, if none of the people on the table are talking, or let's say you're going to the restroom, so you start moving, your smartphone will automatically detect these events. And it will send notifications. It will withhold notification until such moments actually happen so that it won't interfere with your socializing. The next one was actually also involving notifications. And one of the observations that we had was, now if we're actually with somebody in the same room, you try to first detect somebody's context. If somebody is busy, you try not to interrupt. However, in the mobile messaging scenarios, you really don't know what the other person's doing. So you just send that message or whatever notification, and it's up to the receiver who has the burden of whether to check or not to check, even if that person's in a very difficult situation to check notification. However, when you get the notification, you still have the urge to check. So we thought this was kind of unfair because we put all the burden to the receiver. So what we devised was that so there's a private status sharing. So if you want to let some people know, for instance, your good friend or family members, that what you're doing, what your status, what your context is, when that person sends you a message, for that sender, there will be actually notifications saying, hey, the person you're trying to message to is, let's say, driving or giving an interview or giving a presentation. Do you still want to send a notification? So the sender actually has to decide whether this is so important that you still want to send notification versus no, it's okay. When the receiver is in a status where it can check the message, then send a notification, right? So the message is actually delivered, but the notification is withheld. So this would help the people not be interrupted when they're doing something very important. Now, another interesting part of mobile application these days is that now apps are called super apps, where they have many different features within. For instance, your social networking app typically has, let's say, if it's like a picture viewing, it's not just viewing the picture. There are some short videos. There are parts where you can search, recommended feed. You can actually message, leave comments, many different things. And when we happen to overuse these apps, sometimes we feel like, I didn't actually go to this app to use certain features, but I end up using these. So instead of analyzing each user's smartphone usage on the app level, we actually came up with a technology that could analyze the usage at the feature level. So with that information, people can actually see how much time they use in each feature, so that people can actually reflect. And our study revealed that using the regret theory from economics, with this information, people were actually able to reduce regretful smartphone use. Now, with this technology, the obvious next study is to actually do the interventions. So, with digital well-being being a very important topic, people kind of can reflect how much time I spent on each app, maybe in a daily or weekly basis. But again, we want to study what will be the difference if this is done on the app level versus the feature level. Now, as you can see, if we provide your usage time based on the feature level, it's more fine-grained, and people can reflect better, and maybe they could decide, okay, maybe I want to spend less time on certain features and help them, reduce the smartphone usage that they might regret. So we have built this, and with the user study that we have, when people were provided the opportunity to self-reflect the feature level, they spend less time on more passive usage of the apps. For instance, like just reading comments or just browsing through something that they weren't intended to do. Now, the last topic, but not the least, we also touched on several different aspects of mobile computing and also networking. This involves, for instance, the mobile developers, app developers, but also mobile users. The first one I want to introduce is called Crossdroid. Now, let's say if you're an app developer and you have a new feature that's really cool that you want to develop. However, that new feature can't just be standalone. It has to build on top of existing features, but then you end up having to implement the whole thing that already exists, let's say in a certain different app. However, those apps are typically not open source, so it's very hard. So you have to basically reinvent the wheel. So we developed this tool called Crossdroid, where if you have an app where you want to utilize a feature, even without the source code, you can actually build your own just by actually drawing up how you want to use the existing app. So you borrow the functionality. And through our new prototype, through the user study with the mobile app developers, without Crossdroid, people had to write more than 10,000 lines of code. But with Crossdroid, they only had to write 51 lines of code and accomplish the same functionality. The next thing is to actually look into thermal behavior of smartphones. So when smartphones and apps came out, a lot of people initially focused on the energy efficiency because people didn't want to run out of batteries. However, as there are more advanced apps that utilizes your camera, for instance, smartphones got hotter, right? So when you're doing video conferencing or doing interactive games that's very video intense, the smartphone got very hot. Now, smartphone cooling is very difficult compared to other computing resources because it just can't use the similar technologies on the phone. But people quite didn't understand how the thermal behavior works based on people's app usage and so forth. So we were the first one to actually perform a very fine-grained measurement and user behavior analysis. The last part is networks. So this is utilizing my background on wireless networking. So in many different scenarios, especially in the military, when there are drones, for instance, or even mini robots that they have to be deployed where the people can go and monitor or do surveillance or do some mission. And these multiple devices, they have to communicate with each other in wireless communication. However, it's really hard to deploy like LTEs or Wi-Fi access points. So they actually have to communicate multi-hop to communicate. And with the mobility and limited bandwidth and so forth, this is extremely difficult. So we have some routing protocols and also metrics for routing that enable these multiple devices on air, can communicate either images or data or even videos. So in the demo here, we show the routing as well as multicasting using real drones. So those are some of the highlights of the research that we do in the lab. Just want to talk a little bit about the accomplishments that we have made. The thing that I'm most proud of is the student achievements. So I have listed several members in the lab and many different awards they have won. And this is something that we're very proud of. Another thing that I'm also personally very proud is that all my students, when they went to interview for international industry positions, whether it's full-time jobs or internship, everybody who interviewed actually got the offers. And I think that's a testament of the independent research and English fluency and world-class research that our students have been doing in our lab. In terms of some of my achievements, in order for me to come to KAIST after the industry experience, I had to do a lot of work, but I believe my career has advanced even further at KAIST because of all the top students that I have. So I have won many best paper awards with the students in the top conferences, but also were able to be recognized and chair and demonstrate international research leadership in top venues around the world. Just want to mention some of the conferences that we have published. Again, these are extremely prestigious, selective conferences. So I categorize them into three different areas. In the mobility space, top conferences such as MobiCom, MobiSys, UbiCom, Census. In terms of machine learning conferences, Neuralabs, EMNLP, and HCI, ACM Chi, US, and CSCW are some of the conferences that we have published in. So to conclude, we utilize our expertise in many different areas, including mobile computing, machine learning, human-computer interaction, and network systems to build innovative services and applications that could help improve your lives. Thank you for listening, and I hope to connect with you again soon.